In this session, we are going to introduce a density-based clustering algorithm called DBSCAN. DBSCAN is a density-based spatial clustering algorithm introduced by Martin Ester, Hans-Peter Krieger's group in KDD 1996. This paper received the highest impact paper award in the conference of KDD 2014. This paper developed an interesting algorithm that can discover clusters of arbitrary shape. Actually, DBSCAN itself is an acronym of Density-Based Spatial Clustering of Applications with Noise. The method introduced a new notion called density-based notion of cluster. That means a cluster is defined as a maximal set of density-connected points. It defines two parameters, one called epsilon, or EPS, is the maximum radius of the neighborhood. That simply says if you have a point Q using the radius epsilon, suppose it's 1 cm, you want to find how many points include in Q's disk. The minimum points, minimum number of points in the epsilon neighborhood of a point. For example, you can define minimum point is P, then this Q for sure is quite dense because it contains like 11 points within its radius. Then we can define the epsilon neighborhood of a point Q, which is defined as follows. For any point P, its distance to Q, if it's less than or equal to epsilon, then this P actually belongs to this epsilon neighborhood of Q. For example, if you look at this point, you probably can see, if you think this one is Q, its neighborhood is including like 5 points, so this one we actually can call this one as a core. But if itself does not have that many neighborhood, but it can be reached by the cluster, we call it as a border. But if it's isolated itself, cannot form a cluster, cannot be reachable by other clusters, we call this one as outlier or noise. Now we look at a concept called directly density reachable. Directly density reachable means, for example, P is directly reachable by Q. The reason is P actually is within Q's epsilon neighborhood. On the other hand, Q itself is a core point because Q's disk contain number of points is greater than the minimum number of points. Then we define another notion called density reachable. Density reachable means a point P is density reachable from a point Q with respect to the radius, epsilon, and minimum number of points. If there's a chain, there's a transitive closure, okay, you get a point at P1 to Pn, P1 actually is Q, then you can go to P2, then P2 is density reachable to P eventually. Then we will say these P, I plus 1 is directly density reachable from Pi, then finally P is density reachable from a point Q because there's a transitive closure of directly density reachable. Then we define another notion called density connected. Then we can say point P is density connected to point Q if there exists a point O which is density reachable to P and also density reachable to Q. That means P and Q both can be at the border, but as long as there is a point O which can be directly density reachable to these 2 points, then these 2 points are density connected, or we say they are in the same cluster. So we introduced then the DBSCAN algorithm. The algorithm actually is saying arbitrarily select a point P. That means at the very beginning you can select any point as starting point. Then you retrieve all the points density reachable from P with respect to epsilon and minimum number of points. That means you try to find from this P how far you can density reachable. That means you first find directly density reachable, then find its transitive closure, or the reachable one. Okay, that means you find a core, then you find a border. Okay. If P is a core point, then the cluster is formed because you reach from anywhere you finally can reach it. But if P is a border point, like this one is a border point, this one is border point, then no point are density reachable from P. For example, like this point, okay, no point can be density reachable, then you will think this one is a noise or outlier, okay. Then the DBSCAN will visit the next point in the database. That means you try to find a new point to start. You will continue this process until all the points have been processed. So this is the algorithm. This algorithm is quite efficient in the sense, if you use spatial index, so access its neighbor is very fast, then the computational complexity of DBSCAN is O(n) log n, where n is the number of database objects. Okay. Otherwise, the complexity is O(n) squared because you have to check all the points every time. But comparatively, this one is still pretty efficient algorithm. Okay. However, DBSCAN is sensitive to the setting of parameters. This one was published by Crisp's group in 1999 in Computer magazine. They show the DBSCAN, for example, if you set minimum number point is 4, but epsilon you set this disk size, the radius size is 0.5, you actually find a pretty nice clusters. However, if you set 0.4, you probably can see the cluster you find many, but they are pretty ugly. Okay. For the same experiments, you probably see for these number of points, if you set minimum number of points is 4, the epsilon is 5.0, you find a cluster like this. In principle, you probably even should find 2 clusters. On the other hand, if you set a point 3.5, you find a bunch of clusters, but they break a nice cluster into many. Okay. If you set a point 3.0, you will find pretty ugly things because there are many, many small scattered points. You find many small clusters. Okay. So we may need to invent another method, try to fix this one. That means to make the method less sensitive to the setting of parameters. This is the one we're going to discuss in the next session.